Hello everyone. Welcome to the solution of LeetCode problem 1038 named binary search tree to greater sum tree. In this problem, we are given the root of a binary search tree and we have to convert it to a greater tree such that every key of the original binary search tree is changed to the original key plus the sum of all of the key greater than the original key. Here, as a reminder, a binary search tree is a tree that satisfied this constraint. Here, the left subtree of a node contains only nodes with the key less than the original node, and the right subtree will contains the nodes with the key greater than the original node, and both of the left and right subtree must also be a binary search tree. So here, let's understand the first example. Here, the root is 4, which has two children, 1 and 6. 1 has two children, 0 and 2. 2 has one children, which is 3. 6 has two children, 5 and 7. And 7 has one children, which is 8. So here, suppose let's understand this node 6. Here we have two nodes which is greater than 6, which is 7 and 8. So their summation will be 15. So 6 will be replaced by 15 plus 6, which is 21. Similarly, by applying the same logic, we have to replace all of the nodes value in the given input. I hope you understood the problem statement. Now let's move on to the algorithm. Here, to understand the algorithm, we have taken this similar example and we will use the depth first search algorithm to solve this problem. But here, suppose for each of the node, we will traverse the right subtree first. After that, we will traverse the left subtree. Why we traverse the right subtree? Because as the given tree is a binary search tree, all of the value of a node in the right subtree must be greater than the current root. And similarly, all of the value into the left subtree must be smaller than the current root. So here, we will simply process the right subtree first. After that, we will process the left subtree. So DFS start from the root node 4 here. So from 4, we will go its right subtree, which is 6. From 6, we will go to 7. And from 7, we will go to 8. Now, let's take a variable, which is sum initialized with 0. Now, from 8, we will return. So it will return 8 plus sum, which is 8. That means this 8 represents the value of the node itself plus all of the nodes which is greater than 8. So here we do not have any of the node which is greater than 8. So we have to return 8 instead. The 7 will return the value 7 plus 8, which is 15. Or we can replace 7 by 15. So what this 15 means? It is 7 plus 8. That means 7 is the node itself and 8 is the value which is greater than 7. So it is 15. Now we are at this node 6. So here the node 6 value will be replaced by 21, which is equal to 15 plus 6, 21. Now we are at this node 5. And here node 5 will return the value 5 plus 21, which is 26. That means this 21 basically represents the summation of all of the node greater than 5. So it will be 26. Now from 6, we will return to 4. And 4 will become 26 plus 4, which is 30. Similarly, from 4, we will get back to 1, and from 1, we will get back to 2, from 2, we will get back to 3. And these 3 will become 30 plus 3, 33. Where 33 represents, or this 30 represents basically the summation of all of the node greater than 3. Now from 33 we will get back to 2 and it will become 35. From 32 or 35 it will get back to 1, it will become 36. From 1 it will get back to 0 and it will become 36, and from 0 we will return to 1, and from 1 we will return to 4, and from 4 we will dismiss the algorithm. So here we can see that the root value becomes 30, it's become 36, 36, 35, 36, 26, 21, 15, and 8. So here all of the value in the node being replaced by using this algorithm. This is how basically we're gonna solve this problem. I hope you understood it. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named bst to gst, which has a root as a parameter. And if the root is null, we have to simply return null. Otherwise, we have to recursively call this function into the right subtree. And root value will be replaced by root value plus sum, and sum will become to root value. And after that, we have to recursively call this function into the left subtree. Finally, we have to return the root. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.